Part 2 wants us to prove that they're skew. Now, two lines are skew if they aren't parallel but don't intersect. So from part 1 we've already shown that they're not parallel since they're perpendicular. So that bit's covered. So we just have to show that they don't intersect. And in order to show that they don't intersect, what we do is we say that if they were to intersect, the x components or the I components on the first equation will need to equal the I components on the second equation. The j components will need to equal the j components on the second equation. And the z components or the k components will need to equal as well. So what we do is we assume that they are, we try to work out what s and t value would make them equal, and just by using any two of these three equations, and then show that when we get down to the third one it doesn't actually work. So I am going to take the top two, I'm going to use 1 and 2, find out what s and t value makes those two consistent, and then show that that s and t value doesn't work for the third one. So I'm going to take my equation 1, I'm going to have two lots of this equation 2, because then I'll have two t's on both of these. So then if I add them together, the t's will disappear. So that gives me an s value of 3/5. If s is 3/5, what's t? So s plus 3 lots of 3/5 will be 9/5 equals 2 plus 2t. So that's 3 plus 9/5 is 2t. By my calculator, 3 plus 9/5 divided by 2 is 12/5 for t. So let's now go and check if that works on number 3. So equation 3 was minus 2 plus 2s equals 7 minus 5t. So that's minus 2 plus 6/5, because s is 3/5, equals 7 minus, well that's going to be 12. 12/5 times 5 will be 12. So you can straight away see this is integer, this is not integer. Minus 2 plus 1 and 1/5 will be minus 4/5. But this will be minus 5. So they're not consistent, inconsistent there. So skew.